if I have an axis like this, and I rotate this axis a certain number of degrees, I'm going to rotate it 45 degrees, and then I'm going to move it off by 10, 20, okay? And then in order to make this taller, I'm just going to extend this curve and uh, split it by the height of the. Okay, so if I revolve this curve, um, revolve 360 degrees like that, that's a hyperboloid. Okay, so if I take this hyperboloid and I rotate it 180 degrees about one of its isocurves, I get this configuration where they nest together. And if I mirror about 2 points on the axis and 1 point on the isocurve, which basically is the same as mirroring about a like a plane through the axis, like that. If I mirror this isocurve, that I get the other isocurve that's also in the surface. And then when I rotate this, I can split both of these surfaces by those two isocurves. And it's displaying weird, but that's nothing. If I were to rebuild these with a lot of the, it's producing something funny here. Let me remake this. Looks messed up. Okay, so here I have my isocurve, and I'm going to revolve it 360, and then I'm going to take it, mirror it about its midpoint and 2 points on the axis. And then I'm going to split this surface by both of those, and I'm going to revolve it, rotate it 180 degrees about one of those axes. And now it's displaying weird, but if I rebuild these, a lot of points, we can see they nest perfectly together. Okay, so that's what I'm going for. But to backtrack a little bit, just looking at the hyperboloid, if I take a plane vertically through the axis, this, and I intersect it, I get these curves. So if I divide one of those, actually divide into 5, maybe I'll do 6, and I extract these isocurves. Okay, I've got those circles, bottom and the top. Excellent. Okay. So now I've got all these circles and my two crossing isocurves. Okay, so all I'm going to do is um, just turn my perp snap on and draw a bunch of lines up one side of the hyperboloid like that. And then I'm going to mirror that over there. Okay, and then I'm going to, let's put these on their own layer so we can see them. Uh, it goes from there. So basically, I've got two kind of curves like that. Okay, so then I'm just going to fill it with a zero radius, get all these triangles. And then I'm going to split these curves in half. I don't really have to do that. I just find that Rhino screws up less if I'm doing half. Okay, and then I'm just going to delete half. Okay, and then I'm just going to extrude them to their points. That one goes, this one goes there, that one goes there, that one goes there, that one goes there, there, that one goes there. Okay. And then let's put these on the layer we can see them. And basically, what I could have, by the way, just like lofted this and this. But the reason I didn't do that is sometimes it splits it up into kind of funny bits. If you make a cone, it's sure to be, but it's the same principle. And then I'm just splitting these. Okay. Gonna mirror it because that one's coming out here. Okay. All right. So now I've got this discretized conic surface of revolution, and I can mirror that over there, and I'm going to delete all these. So now what I want to do is show crossing things, and you can see if you look closely, it's only touching in these points. There's kind of a gap in there. Okay, so what I can do is extract an isocurve. So if I were to rotate this 180 degrees, they're going to self-intersect like that. What I can do is I can extract isocurves where they do hit. And I can get rid of the portion of the surface that's over here. Like so. And then I can put this on type 1, type 2, type 3. Let's type 3 again, type 2, type 1. Unfortunately, this surface is going to have some weird ends. Like I'm going to have to um, get these little bits and make the end types. Then if I divide this up, like let's say I divide this into four, all of those are one type. But then these last ones might be like five, six, seven, eight, seven, six, type five. Okay. And then yeah, just add here this rotate 3D like that. And that is another one with now six types.